All right, problem 3-55. If the cooling system in a light water nuclear reactor is shut off, the temperature of the fuel rods will increase. The temperature of the fuel rods during the first hour could be modeled by the equation T equals 680 times 1 and 4 10,000ths raised to the power of T minus 655, where lowercase t is the time in seconds and capital T is the temperature of the fuel rods in degrees Fahrenheit. Average rate of change can be calculated by finding the slope between 2 points. Find the average rate at which the temperature changes for the first 30 minutes. So some key things here to focus on here is our lowercase t here is going to be the time in seconds. That's a key part of this here. Remember, always want to define variables when you're dealing with some sort of algebraic function. So we also have T is, capital T is the temperature of our fuel rods in degrees Fahrenheit there. So that's what this whole entire equation that they've given us is finding, is the temperature based on the number of seconds. So we're trying to find the average rate of change, and they said that we can find that between any 2 points in our equation here. So the points they want us to use are our starting point. And if you think about it, the starting point would be after how many seconds? That's right, that would be 0 seconds. So we're going to have to figure out what the temperature of the fuel rods is when it starts here. Then we're also going to need to find after 30 minutes. So we can't just put 30 in there because remember, T is going to represent the number of seconds that have gone by. So we'll talk about that one here in just a moment. Let's figure out here first of all what the temperature is going to be at the start here after 0 seconds. So let's take it here, and if our input value is the number of seconds, we're going to put 0 into our function for our lowercase t. So we're going to end up with T equals 680 times 1.0004 raised to the power of 0 minus 655. Well, we know anything raised to the power of 0 is going to be 1, so that makes that easy for us to do. We have 680 times 1 minus 655. Well, 680 minus 655 should give us 25. So we know that our T will equal 25 when capital T will equal 25 when our lowercase t is 0. So we're talking about 25 degrees Fahrenheit there. Our second point that we're going to be dealing with here when we're finding our average rate of change is going to be when 30 minutes has passed by. So what we have to think about there, if we have 60 seconds is equal to 1 minute here. Well, if we want to convert our 60 seconds to 30 minutes, we're going to need to take it and we're going to need to multiply it by 30. So 60 seconds times 30 is going to give us 1,800 seconds. You can check it on the calculator if you need to. But our input value for our second function is going to be 1,800. And we need to figure out what the temperature is going to be then. So now that's a little bit bigger number here, so let's go ahead and let's get out our graphing calculators here, and we can input these numbers in to figure out what our values are going to be. So I'm going to take this, let's get it out. We've got 680 times 1.0004. Let's close it. Let's raise that to our number of seconds, which is 1,800 seconds. And then we still need to subtract our 655. So our input there, 1,800 seconds. Our output should be 741.8134812. So we'll take that and we'll say here that we'll just go ahead and round it to the nearest hundredths place there. So 741.81. So 741.81 degrees Fahrenheit. And now what we're going to have to do here is they want us to find that average rate of change. So a starting point was at 0 seconds. We were at 25 degrees Fahrenheit. After 1,800 seconds, we were at 741.81 degrees Fahrenheit. Remember, rate of change is the slope. Slope comes from the change in our output values over the change in our input values. So I'm going to take it and I'm going to set up here my average rate of change. I'm going to call it my ARC for this one here. We're going to say 741.81 minus 25. And we're going to divide that by 1,800 minus 0. And when we do that there, we can actually take that and let's use our calculators for that there too right now. So let's take it, let's just do it all at once here. We're going to have 741.81 minus 25 over 1,800 minus 0. I'm just going to go ahead and put in 1,800. No sense in putting the 0 in there. And let's go ahead and hit enter. And we're going to get, if we round it to the nearest hundredth, we have 0.39822 and so on there. If we round it to the nearest hundredth there, we're going to end up with about 0.40. Which means there, remember this is our temperature over the number of seconds. So what we'll end up be changing here is we're going to be changing about 4/10 of a degree every second. So our average rate of change is about 4/10 of a degree Fahrenheit per second. And if you still have questions about this problem, or there's something you don't understand, please make sure that you ask your teacher in class. I hope that helped out a little bit. Have a good day.